Alright, in this video we're going to talk about Roman numeral 5 type problems, and we call these the Jennifer Lawrence problems because of the scene in the Silver Linings Playbook where there's a dance competition and they need to get an average score of 5. A number of the judges have already turned over their scores, but one judge's score is still not showing, and we needed to calculate what that judge's score would need to be in order to get them an average of 5 to achieve their goal. So, first example, Barbara's math course has 4 tests and 1 final exam. The final exam counts as much as 2 tests. So she has scores of 78, 80, 100, and 96. Now, the final exam, which is going to be scored between 0 and 90 and 100 still, is going to go in as 2 different exams, and you would do that to make it more valuable, to make it have a greater weight in the calculation of the final grade. So we're going to add up all those scores, including the placeholders for the missing final exam. We're going to divide by 6 because we essentially have 6 scores, not just 4 or 5. So we're going to include the final exam as if it were 2 tests. And we want the average to come out to be 90. So if we were to then add these up, we would get 78 plus 80 plus 100 plus 96 plus, oh, that's it. And yeah, we can't do that. Sorry, I added an extra 354 in there. So 78 plus 80 plus 100 plus 96 gives us a total of 354. Plus the 2x's divided by 6 is equal to 90. Here we would multiply both sides by 6 to get rid of the denominator. That's the purpose of that. And we would end up with 354 plus 2x is equal to 540. Subtracting 354 on both sides would give us 2x is equal to 540 minus 354, or 186. So that x would have to equal 186 divided by 2, which is 93. So we know that she would need a score of 93 on the final exam to have an average of 90 for the course. And that's going to do it for this problem here. So if you were to go back and take a 93 and plug it in for both of those x values, counting that final exam score twice, adding up the scores in the numerator, dividing by 6, you would get an average of 90 there. Alright, we're going to go on to the next example. In this problem, a teacher tells Melinda that she has a course average of 78 on her 6 math tests. When she got home, though, Melinda could only find 5 of the tests. She had scores of 87, 63, 79, 71, and 96 on the 5 tests, and she couldn't find the 6 tests. But we're still going to put a placeholder there, a variable of x, so that we can include it in our calculations and figure out what that value should be. We're going to divide all of that by 6 because we do have 6 tests. Even though we only have 5 numbers, the placeholder x is there representing the 6th test, and so we're still going to divide by 6. And the average the teacher said was 78. So when we add these values up now, we're going to get 87 plus 63 plus 79 plus 71 plus 96 is going to give us a total of 396 plus x divided by 6 equals 78. Multiplying both sides by 6, we would get 396 plus x is equal to 78 times 6, which is 468. Subtracting 396 on both sides, we end up with x is equal to 468 minus 396, which is 72. So that must mean that her missing sixth test had a score of 72. Go on to a few examples from the picture packet. So from page 2 of the picture packet, we had this problem where you want to bike an average of 5 miles per day, and the table shows you how many miles you've already biked. So Monday was 3.5 miles, Tuesday 5.5 miles, Wednesday you didn't bike at all, Thursday you biked 5 miles, and Friday you want to know how many miles you should bike in order that when you divide by 5 for 5 different days, you would get an average of 5 miles per day. So we're going to first add up our values here. 3.5 plus 5.5 plus 0 plus 5 gives us 14 for the 4 days that have already passed. And we're going to add in the missing 5th day, divide by 5, get an average of 5. So we want to get rid of the denominator, multiply both sides by 5, and we have 14 plus x is equal to 25. Subtracting a 14 on both sides, we'll get x has to be 11. Now that makes sense. It's a really big number. It's actually double what you biked on the longest ride of Tuesday. But that's because Wednesday you didn't bike at all. So you have to make up those 5 miles. You have to make up the 5 miles for Friday, and you have to make up a deficit on Monday where you only biked 3.5 miles. So you would have to bike 11 miles on Friday to have an average of 5 miles per day for those 5 days, not 5 miles. Alright, we'll take a look at one final example. Also from the picture packet, page 3. The scatter plot shows the attendance for each meeting of a gaming club. The first meeting, 18. Second meeting, 21. Third meeting, 17. We're asked in part A, the mean attendance for the first 4 meetings is 20. You know that the 4th meeting, which we don't know how many was there, when it's added to the other 3, will give us an average attendance of 20. And the question is the number of students attending the 4th meeting going to be greater than or less than 20? Well, we know the first meeting was below the average by 2. The second meeting above the average by 1. The third meeting below the average by 3. So far we have -2 plus 1, that's -1, plus -3. We have a deficit of -4 going into the 4th meeting. So the 4th meeting not only has to hit the average, it has to make up for what was missing from the previous meetings. And so we definitely know it has to be more. And the part B says, can we estimate? Yes, we know we have a deficit of 4 going in, so the 4th meeting would have to hit the 20 plus make up the deficit. So we think that it's going to be 24. So let's go ahead and actually calculate this out. We have 18 plus 21 plus 17 plus the missing 4th meeting. we're going to divide by 4, and we want to hit an average of 20. When we add up our scores, the attendance numbers that we do have, we have 18 plus 21 plus 17. That gives us 56 for those that we know, plus the missing fourth meetings attendance divided by 4. It's got to be 20. We're going to multiply both sides by 4, and we end up with 56 plus x has to equal 80. Subtracting 56 on both sides, we get x is equal to 24, which is exactly what we expected. So the fourth meeting attendance would have to be 24 to get an average of 20, an average attendance of 20 over the 4 meetings. And that'll do it for this problem and for this problem type number 6.